Okay, chapter 2 is combinational logic circuits. We will start in chapter 2 to draw circuits. The overview of the chapter, we will explain what are gate circuits and what are Boolean equations. So what is a binary logic, what are gates, what is Boolean algebra, and what are the standard forms. We will also explain in the part 2 how do you optimize a circuit, okay, and how do you map manipulation from one circuit to another. You will learn how to do the mapping, and we will learn how to do practical optimization and then multi-level circuit optimization. Okay, so I will start with the first part, which is what is binary logic and what are the gates that we need to draw a circuit. We will learn, I repeat, in this chapter how to draw circuits. Okay, so the digital circuits, they are hardware components that help you manipulate the binary information. When I say manipulate, it means you can do OR for them and not. The circuits are implemented using transistors and interconnections in complex semiconductor devices that are called IC or integrated circuits. Each basic circuit is referred to as a logic gate. We will start with what is a binary variable. A binary variable can take one of the two discrete values. So if you have letter A, the output could be a 1 or a 0 since it is a binary. Okay, you have B, you could name it C, X, Y. These are naming convention and they are up to you to select what is the name of the variable that you want to use. Logical operators, they operate on the binary values or the binary variables. We have three basic operators you need to be aware of. We have the AND, the OR, and the NOT, and you will explain the difference now. Logic gates, they implement logic functions that you are doing. So if you are doing an AND, you need an AND gate. If you are doing the OR operator, you need the OR gate. If you are doing the NOT, you need a NOT gate. So I have three gates, each gate for a function or an operator. Boolean algebra is used as a mathematical system for specifying and transforming logic functions to make the equation simpler. So we have less circuits or less gates in the circuit. We study Boolean algebra as a foundation for designing and analyzing digital systems. We have now two binary values, if you recall, true, false, on, off, yes, no, 1, 0. We will be using 0, 1. That's it. This is what we will be using in our circuits. Okay. Variables identifier could be A, B, X, Y, Z, maybe X1, X2, X3. They are names that you give to your variables. What are the three logic operations? You have AND, OR, and NOT. We denote the AND by a dot, or it also could be denoted by this as an AND, or is denoted by a plus, or it could be denoted by this. NOT is denoted by a bar or one single quote, A prime, or a tilde. We usually use the prime and the bar. Okay, so when we are saying NOT, we say A prime or A bar. Okay, this is what we commonly use. Now let's go over examples of the notation. When we are reading A dot B, this is read, you read it as A. Okay, Y equals A and B. Z equals X plus Y, you read it as Z is equal to X or Y. And X equal A bar, you read it as X is equal to not A or A bar or A prime. Okay? When you are doing in arithmetic the statement 1 plus 1, it is equal to 2. But here, when you are doing 1 or 1, you are actually doing an OR operation. So the answer of 1 or 1 will be a 1. You are not adding them up, you are ORing them. So you are selecting 1 or a 1, of course it will give you a 1. So this is a Boolean operator. It is not an arithmetic where you are adding, you are ORing. What is a truth table? A truth table is a tabular listing where you actually list the values that you have for all the possible combinations. So we will start with the AND. It is very important that you understand how do we get the output of the and how do we get the Z equals X and Y. So I will start with the first one, please, and I need your help. When I have X equal to 0 and Y equal to 0, what is the result of Z when I do X
X
and
and Y.
Y, yani 0 and
And
0? This will give me a 0 as the output, right? What about 0 and 1? It's also, the output is also a 0. What about 1 and 0? The output is also a 0. The only case in the truth table of an AND where I have a 1 is when X is 1 and Y is 1. When I do the AND, I will get a 1. So this is the truth table for the AND gate. Okay?
But doctor, why zero and one give zero?
It is also a 0. The two inputs must be 1 to get an output of a 1 in an AND gate. Okay?
Doctor, so and is multiplication?
It is, exactly. Okay? We move to the OR. OR, I have 0, 0. So if I OR them, I will get, of course, a 0. 0 or 1 is a 1. 1 or a 0 is also a 1. And 1 and a 1, 1 or 1 is also a 1. So the only case that you get a 0 in the OR is when all the two of the inputs are 0. So 0 or 0, of course, you are selecting between a 0 or a 0. So it's going to be a 0. Other than that, if you have one of the input to be 1, you will have an output of 1. Clear for the OR?
مش مفروض 1 plus 1 تكون 2.
It is not a plus, it is an OR. OR.
Okay.
So you choose an X or a Y. If one of them is a 1, you actually selected a 1. Whereas in the AND, the two must be a 1, so you have a 1. Okay?
Okay.
We move to the NOT. NOT is automatically the complement. If you have an X, a 0, the NOT is a 1. If you have X, a 1, if you do a bar for it, it's going to be a 0. It's the complement. Okay? Clear the truth tables of the AND, the OR, the NOT. Any question? Okay. We start now with the gates. When you are drawing a gate for the any operation, let's say the AND, you need to specify the input and the output, and you draw the actual gate. Okay, so we start, please. The input of the AND gate, this is the AND gate. It has two inputs, 1, 2, and one output, which is the Z. So this is the input X, this is the input Y. They are designated by a wire that goes as input to the AND gate. This is the AND gate. And you get one output out of the AND gate, which is Z. In this case, please, when do I get a 1 on the Z?
when both of them are 1.
Perfect. When X is 1, Y is 1, I get a 1 here. Hiba. If I have X equal to 0 and Y equal to 1, what is my Z?
0.
Perfect. What about you, Carmen? When I have a 0 and a 0, what is my Z?
Also a 0.
Also a 0. So the only case where I have a 1 on the Z in an AND gate is when X is 1 and Y is 1. You got the idea? We move to the OR gate. This is the OR gate. You have two inputs, X input, Y input. They are drawn as wires. And the output is Z, where Z is X or Y. Fine. When do you get an output of a 1 in an OR gate? Yes, Ray, please.
Okay, if x equal 0, y equal 1, take 1. Take one of them.
Perfect.
As
Okay.
long as one of them is 1.
Exactly. So if x is 1, y is 0, the output is 1. If x is 0, y is 1, the output is 1. If x is 1, y is 1, the output is 1. The only case where z in the OR gate is 0 is, yes please?
Both of them are 0.
Or 0.
0, 0 will give you an OR output of a 0. We move to the NOT gate.
Doctor, I have a question.
Yes, please.
We work X and Y like binary, right?
Yes, they are binary
We
input.
have 2 or 3 or 4.
Yes.
Only 1 and 0.
0, 1, yes, yes. We won't use true and false. We will use 0 and 1, which in your mind, 0 is a false, right? It's an off. It's the same, but we will be adopting the symbols 0 and 1 only in our circuits, okay, when drawing. And then for the NOT gate, x is a 0, you get an output of a 1. X is a 1, you get an output of the 0. It is simply the complement, okay? By looking at the question about drawing the logic gate. Yes, please.
Doctor, in what case we have like in x0 and y0, the result will be 1? I've heard like something like this.
In the AND gate?
Yes.
No, in the AND gate, you must have two
Or
ones.
or gate, I think. My
The
bad.
OR gate, if you have one of the values to be 1, you will get an output of a 1.
No, I've heard like 0 and 0 and 1 and 1 like بيعطونا 1 as a
4
result.
inputs. You have 4 inputs.
No, 2 inputs. 0 0 1 1. اثنيناتهم بيعطونا 1.
You are listing for me 4 inputs.
Yes, انه بس قصدي الماتشنج like انه 0 مع 0 انه 0 or 0 1 or 1 because جربت اعمل كم شغله.
So let me look now at the waveform behavior in time for every gate, okay? So I will start here. I have values x and y, these are my variables, and this is the AND gate. Look how do you read the waveform. You have 0, 0, it will give you output of a 0. The 0 here remained a 0, but the y, 0 changed to a 1. Okay, so now I have a signal. 0, 1, it will also give me a 0. Here the 1 changed to a 0, but also the x changed to a 0. So 1, 0 is also a 0. Now this remained a 1, but this changed to a 1. So now I have 1, 1. This will give me a 1. I repeat myself, the only output that gives me a 1 in the AND gate is where my 2 inputs are 1. This is the only case where I get a 1. We move to an OR, which you have x or y. So 0 or 0 is a 0, 0 or 1 is a 1, 1 or 1, 1 or 0 is a 1, 1 or 1 is a 1. This is where you actually have the complement or the negation. If you have a 0, it will give you a 1, still a 0, it will remain a 1. Now change the x to a 1, the x bar will be a 0, and of course, if it is still a 1 here, the output will remain a 0 here. You got the idea? Okay, this is only a different way of showing you the behavior in time for every logic gate, depending on the changes in the input that you have. Okay. Now, you need to know that there is a delay. You don't directly get the output out of the physical gate. If you have a 0 and a 1 and it's going through the gate, you don't get directly the output, okay? There is a delay. This delay could be in nanoseconds measured, and the delay could be 0.3 nanoseconds, 0.1, 0.5. It varies from one type of a gate to another. So if you have the input of 1, and also here you do not get directly the output, there is a delay where the output will remain 0, and after the delay passed, which is 0.3 nanosecond, now you get the output. You got the idea? So here you have a delay of 0.3 nanosecond where the input is 0, the output won't change. See, the output is still 0. When did it really change? After 0.3 nanosecond, you got the output. Clear? So So I was just trying to tell you that if you give input to the gate, it is not an instant output. You have a delay of 0.3 nanosecond, and then you get the output. This is why there is a delay when doing execution on the computer. You don't actually, we are working on gates. You don't get the output directly. There is a delay for every gate. It needs to do the transition, or you get the calculation out of the gate. So of course there is a delay with the output, okay? Let me start with this example of a truth table. I need your help, okay? I'll go over it one by one, and I need your help. How do you, this is, first of all, I have three variables. Let me read the table together. You have three variables, x, y, z. This is called the truth table. The output is f equals x or y bar z. The equation of the circuit is f equals x plus y bar z, okay? And what we are drawing here is the logic gate. What I will do now, I will draw the logic gate with you step by step so you understand how we do it. This is my x, this is my y, and this is my z, okay? First of all, if you notice, I need a knot on the y, so I get a y bar. You agree? Okay, and this is my x, and the y bar here, if I have a z with it, what is the kind of gate that I have here between y bar and z? What is the type of the gate?
And
It is an AND gate.
And
The output coming from the AND gate is x. What is this gate, please?
it's an or.
It's an OR. And I get my F. You got the idea? Do we do
هون
this?
أكيد بنعطي برايورتي للواي مع الزد بالأول، عشان هيك حطيتيهم هيك صح؟
It is not a case of priority. If you are talking about preference, okay, it has to be all drawn. Why I started with the Y, because I have a gate, and the output of this gate will be ORed with X. So this is why I started with Y bar Z. You got the idea? Okay, so I do Y bar.
بس ما بحق إنه نبلش بواي مع إكس.
لا, no, of course, you have to finish this. If parenthesis makes it easier for you, do it, okay? So X is ORed with the output of Y bar Z. So you do Y bar and Z. The output here, what do I have here if I want to write? It is Y bar Z. You agree?
Yes, but Doctor, why did you choose Y bar Z أول شيء؟ كيف تعيدي؟
We do not do X plus Y bar and then you do the Z, okay? This is Y bar Z first, and then if parenthesis makes it clearer for you, add parenthesis, okay? You do the output of Y bar Z and then you OR it with the X.
But doctor, I had a connection problem. Can you please repeat?
Okay, so you do Y bar first, and then you do AND with the Z. The output that you get here is Y bar Z, and then X or Y bar Z will give me F. Okay?
Thank you.
So this is the figure. I drew it with you step by step. Okay? So be careful now. We want to understand the truth table. I need your help. I will start with the first one, which is X equal to 0, Y equal to 0, and Z is equal to 0. How come did I get the output 0 here? Yes, please. Anyone? You can replace the values of X, Y, and Z in the equation, and you calculate it. Yes.
Y will give me 1.
Y will give 1.
1 and 0 be 0.
So if I want to write it down here, let me write it for you. It's going to be F equals 0 or 1.0. You agree?
0. Yes.
Yes.
And
Let's
0
do it,
1 will
please.
give me
0 or 0. Right?
X هي 0 أصلا.
Yes.
Or is 0.
Yes. You get it? Okay. We do another one, guys. Okay. 0, 0, 1. Yes, please. Could you try? Who wants to try? Yala Yara, you try, please. f equals 0, 0, 1. So what is the x? Yara? Okay, anyone else? Carmen?
X equals to 0. وsince إنه عندنا y 0 y bar هي 1 plus 1 so 0 plus 1 equals 1.
You have y bar, right? So 0
Yes.
will become a 1.
Times 1.
And 1. So this is going to be 0 or 1. And of course is a 1. Right? Clear, Carmen?
Yes.
We do more examples. Yes, Ray, can you help? 0, 1, 0, please.
Okay, so x is 0. أول شيء بدنا نحسب y. y1 يصير 0 عنا. So we have 0 and 0 will give me 0. And x, we have 0 multiplied by 0 will give me 0.
Clear?
Yes.
Any question, guys? Did anyone? Is it clear to
Yes.
you? Or you want me to repeat anything?
سوري دكتور عم بقطع لك حديثك بس دكتور لما مثلا ما بلشنا x or y bar وبعدين حطيناها مع z.
It's the same thing, please. You do, if you remember the order of preference, you do the multiplication, you do the not first, the multiplication, then the or. Okay?
Okay.
Okay. So we continue now. What I will explain now is, check. How can I fill this table in a very quick way? Okay? Listen to me very carefully. If x is a 1, does it matter to me what is y bar z? You get the question? I will repeat it. If x is equal to 1, does it matter to me what is y bar z?
No.
Why?
No.
Because 1
No.
or anything is a 1. You agree?
Yes.
1
Yes.
or anything is a 1. So this is why I fill directly these values, 1, 1, 1, 1. Why? Because x is a 1. I don't have to worry about y bar z. You got the idea? So automatically filling the truth table, I check what is the value of the x, 1, 1, 1, 1, and then I fill it directly with the output 1, 1, 1, 1. Now what? How do I fill this? Here I have to do y bar z. I don't have to do or my x because I already know that x is 0. So I only check here y bar z. It will give me 1 and 0. So where z is 0 will give me a 0. Do you agree? Yes, please. Where z is 0, it will give me a 0. So that I directly fill 0 here and 0 here. Okay? And now I have z to be 1. What do? I check the y. If y is equal to 0, put it a 1, it's going to be 1. I put a 1 here. And if y bar, I have a 1 bar, it will be 0. So 0, 1 will give me a 0. So this is how directly fill the table without going one by one with the equation. It will be too long. It will take too much time. Do you want me to repeat it, please? Or you got it? Anyone want me to repeat?
No, it's clear.
Okay. So this is a fast way of filling the truth table. Okay. I have something that I did not mention. How did I fill the truth table very quickly? Look, how do you fill it? How many variables do you have? I will start with having 2 variables. If I have 2 variables, x and y, okay, my 2 cases are going to be 0, 0, 1, 1, 0, 1, 0, 1. This will quickly help me to fill the truth table. Okay, so it's going to be 0, 0, 1, 1, and then I fill the y 0, 1, 0, 1. You got the idea? Now, what if I have 3 variables? Okay, so how many combinations here did I have in 2 variables? I had 4 combinations. How come? I have 2 to the power 2, which is 4 combinations. Okay, now, let's say I have 3 variables. How many combinations would I have?
8.
You will have 8 combinations. How come did we get the 8? It is 2 to the power 3. 3 is the number of variables that I have. It will give me 8 combinations. How do I fill the 8 combinations? Look, I start with the 4 zeros, 4 ones, then 2 zeros, 2 ones, 2 zeros, 2 ones, then 0, 1, 0, 1, 0, 1, 0, 1. Clear? Do you want me to repeat? How do I quickly fill the truth table? I fill 4 zeros, 4 ones, then 2 zeros, 2 ones, 2 zeros, 2 ones, then 0, 1, 0, 1, 0, 1, 0, 1. This will be a very quick way of filling my truth table. Okay? Clear?
Doctor,
Yes, please.
we can think of it كمان إنه as adding a one من
Yes,
stateless state.
Yes, I know, but this will be slower for you to fill in the data for the truth table. When you are doing an exam, you don't have time to add. You will have to think, okay, about it. I am giving you a way without thinking. You fill 4 zeros, 4 ones. Are you thinking about it? 2 zeros, 2 ones, 2 zeros, 2 1. No need to think. 0 1, 0 1, 0 1, 0 1. That's the fastest way. If you want to think about it, look, I will start with the 0 0, add 1, 0 0 1. Now the 2 will be 0 1 0. But you are thinking, okay, now the 3 will be 0 1 1. Okay, 3, add 1 to it, it will be 4. So you see, you are thinking. This way you don't have to think, you just list them. 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 1, 0 1, 0 1, 0 1, you will be ready. Clear? This is the fastest way to fill in the truth table. Okay? Any question, guys? Did you understand how to fill the truth table?
Yes, miss, thank you.
Boolean equations is this. Truth table is this. Logic diagram is this. They all describe the same function. So whatever function you have, whatever circuit you are trying to draw, you can represent it via a truth table or an equation or a logic diagram. They are exactly the same representation, or we are describing the same function. Okay, you wouldn't have a different output in a logic diagram different from its truth table. It must be the same. Okay, truth tables are unique. Expressions and logic diagrams are not. What do I mean by that? A truth table is the output. Where do you have a 0? Where do you have a 1? But you could draw it differently. If you have a complicated logic equation, you could have different drawing. And now we will see examples of these when we are doing the assignment and in the slides. We will have different implementation, okay? You might do X and Y for, not in this example. This example is trivial, okay? But when you have complicated equation, you might implement the circuit in a different way. It doesn't have to be exactly the same for all of you. We start with Boolean algebra. Okay, I will have to say that this is the most difficult part in the chapter. Other than that, the rest is easy. So make sure you understand the Boolean algebra. Okay, I will explain them one by one, and I'm ready to repeat if you don't understand, but please make sure you understand them. Okay, I will start by proving the first one. X or 0 is an X. Let me go over the cases. If X is a 0, you will have 0 or a 0. It's a 0, like X. If X is 1, you will have 1 or 0. It's a 1. So again, like X. Did you understand the first one? Yes, please.
Yes.
Anyone wants me to repeat?
Doctor, can you repeat, please?
Yes, I will. Check, please. X or 0. Okay? X could be a 0 or could be a 1. You agree? So if 1 or 0, it's going to be a 1. If a 0 or a 0, it's going to be a 0. So this is equal to X. See? This is your X.
Okay.
So whatever is X, X or a 0 is going to be your X. Clear?
Clear.
Either X is a 0, you will get a 0. Whether x is a 1, you will get a 1, which is actually x in the two cases. Okay? Did you understand the one? Etienne?
Yes.
If you did, you can explain to me this. Yes.
Okay. In here we're using and.
Yes,
So
you are using and.
okay. X can be either 1 or 0.
Perfect.
If x is a 0, the answer will be 0. And if x is 1, the answer will be 1. So whatever x is, the answer will be x.
Yes. Any question, guys? Okay, who can explain this to me, please? Yes, Jad, can you try? Who can explain x or 1?
بديك دكتور أنا فيه.
My Wi-Fi is a bit slow, miss.
Yes, but I can hear you clearly. What is x or
Okay, I have x plus one. Okay, I have x or 1 equals 1. X can be 0 or 1.
Yes.
If x is 0, then it will be equal 1. If x is 1, then it will be also 1, so it won't matter.
So whatever you are ORing to a 1, it will be a 1. It doesn't
X
matter.
it will be 1.
Exactly, perfect. Okay. Who can explain this to me? Yes, Ray? Number 4.
بتعلق إن كان مس عم بعلق الشباب فيك بس تقولي لي شو قلتي آخر شيء.
Yes, I said correct, Jad. It is correct what you explained. Okay? Yes, please, Ray.
We have x.
Oh, okay, thank you.
We have x or 0.
And.
If x is
It's
0,
and.
sorry, and.
Mm.
Sorry.
Yes.
And the answer will be 0. If x is 1, the answer will also be 0.
So what can you summarize?
X multiplied by
X. No. 0 multiplied by anything is a 0. This is what you can. Yes?
Yes.
Yes. Who can explain this to me, please? This. Anyone?
Yes.
X or X.
Yes.
انه if X is true بتطلع true وإذا X is false بتطلع false انه it follows X.
Exactly. So when you are ORing two x's, it's going to give you x. Whether it is 0 or 0, it will give you a 0. 1 or a 1, it will give you a 1. Are they getting clearer, guys? Carmen, could you try number 6 for me, please?
Yeah. Same goes for x and x. إذا كانت two zeros حتكون يعني in all cases في x حتكون 0. So 0 times any value it's 0.
So 0 times 0, it's a 0. 1 times 1, it's a 0. So it is x. Okay? Sharbil, can you try, please, and explain to me number 7?
Yes, if x is equal to 1 and x isn't equal to 1, therefore it's equal to 0, then 1 plus 1 is equal, 1 plus 0 is equal to 1.
Yes. Yes. This is correct. What about the other way around? If x is equal to 0 plus its complement, it's going to be 0 or 1. So again, it's a 1. Yes?
Yes.
Okay. Who can explain number 8 to me, please? We have another Sharbil. Yes, Sharbil, Sa'ar.
Yes, if x is equal to 0, so x and not x is equal to 1, 0 times 1 is a 0, and if x is equal to 1, the not x is equal to 0, 1 times 0 is a 0.
So you will always have a 0 in this, right? So of course
Yes.
my answer will always be a 0. Very good, very good. Who can explain to me number 9? Any volunteer? Other those who I asked. Someone
X.
else.
Okay.
Someone else.
Yes. It's not x and not x. So it's like x.
Yes. So this is like doing a minus to minus 2. It will give you a 2. You agree?
Yes.
Yes. So x bar bar is an x. Okay? Clear, guys? So this is the first list of Boolean algebra identities, the basic. We continue, please, now with what is commutative. Many of these you already know from arithmetic identities, so they will work the same. X or Y is the same as Y or X. Do you agree? So if you are doing 0 or 1, it's the same like doing 1 or 0. It won't make a difference. Because when drawing the gate, you will have two wires. It doesn't matter which wire is first connected to the gate. So it's X or Y or X. This is commutative. Also, commutative works for the AND. So doing XY is the same, and Y is the same as doing Y and X, because I have two values. That's commutative. We move to associative. Who can explain to me number 12, guys? Anyone? Eli Saba, can you please? Number 12. This is the identity, it's called associative. Eli? No? Elisa?
Okay. It's an or.
It is an
So
or, yes.
it doesn't matter how we group them in parentheses.
Okay.
So it's the same. And x plus y plus z equals x plus y plus z. It's the same.
Yes. So if I have an OR gate, if you think about it, I have here three input, x, y, z. It doesn't matter if I do x or y and the output I give it to the next or I do y or z and the output I give it to the next OR. Actually, OR can take three input gates, okay? Same for associativity. Associative is x and y, their answer and with a z, or you could do x and y and z, okay? How about distributive? This is the distributive loop. If I want to look at it one by one, please pay attention. This is x into y or z. You could do y or z first, and its answer, you do and with x, or you do x or and y plus x and z. Question, how many gates did I use here? Yes, please. How
Two.
many gates? What are they? An OR gate and
And
AND gate. Okay. How about here, please? How many? AND gate, OR gate,
gates.
AND gate. So
Two
how
ends
many?
and one.
Yes. So here I use 3 gates. Here I use 2 gates for the same thing. So this is why I use Boolean algebra. If I have this, I take x as a common factor. This will allow me to use 2 gates instead of 3 gates, which is cheaper, of course, right? Okay, we move to this. This is a bit confusing to see, so make sure you understand it now. You have x or yz. In the distributive law, we have x or y and x or z. So first or the second and first or the third. So if this is 1, 2, 3, you have x or y, which is first or the second, and first or the third. Did you see it? This will be very useful when we are doing simplification. You will need this a lot. Okay? We move to this. This is called De Morgan's law.
Can you please repeat 15?
Yes, I will. Okay. So x or y, z, you have x, y, z. This is number 1 variable, number 2, number 3. If you look at it, it is number 1 or number 2 and number 1 or number 3. So look, please, x or y into x or z. This is called distributive law. George, is it clearer?
Yes, Doctor, thanks.
Okay. So if you
The other one? the left side of the equation is cheaper than the right side تعتبر
By cheaper, you mean you are using less gates, right? So here I am using an OR gate and AND gate, okay? Here I am using one OR, another OR, AND gate. This is less gates than this. Exactly here.
Oh.
This is less gates than this, okay?
Can you please repeat 15?
15. Again, okay. So you have x plus y, z. So I have here three variables. Do you see them? X, y, and z, right? I have three variables. So if I have x plus y, z, I can do first plus second times first plus the third. So you look at it, it is x plus y, أولى تانية, plus times x plus z, first plus third. Okay?
Okay, thank you.
هلا, you will see them better when we do exercises. You will start viewing how do we use distributive, how do we use associative. We move to number 16. This is called the Morgan's law. The Morgan's law, you have x or y, you put a bar on top of it, so you are doing the complement of all the statement. It's going to be x will become x bar, the plus will become a dot, and the y will become a y bar. If you do also x and y bar, what are we really doing? You put a bar on top of x and y, it's going to be x bar, the dot will become a plus, and the y will become a y bar. I think all of them are straightforward and you could understand them, except number 15. Okay? You will get used to it when you see it in the exercises. Any question? Before I do an example, any question?
No, miss.
Okay. Let me start with the Boolean operator. We have a precedence. Like someone asked me in the equation, if you remember, why didn't you do the plus before you did the bar, the and? This is why. This is called the precedence. We always start with whatever comes in the parentheses, then the not, then the and then the or. Okay, so this will explain why we did the not first, then the and then we did the or. Parentheses will make it, of course, easier to understand. When I see a parenthesis like in this example, can you help please? What am I going to do first?
Inside the parenthesis أول شيء.
You could do or, B or C, you get a wire, an output I mean. You do C, you have to do the D bar. Then you do C or D bar, you get an answer. And then A, the output of B or C, the output of C or D bar, you will do an AND for it. Okay? So let me draw it very quickly for you. You have an A, B, C, and a D, right? So here is your B and C. You OR them. Okay? And this is your C. And you need an AND gate on the D and also an OR. And this is my A. Okay, so these three, sorry, this should be one line, and this you could, did you see it, guys? Okay, so this is B or C, so this is an AND gate, this OR gate. This is C or D bar, it's another gate. Okay, and A and the output of B or C and the output of C or D bar with an AND gate will give you an F. Is it clear? Did you see it? Of course you need a bubble here. What? For the D, to get a D bar. Yes, please, any question? So this is the circuit of F. F into B plus C plus D bar.